Alright, I'm creating the video lesson for you guys for exponential growth and decay, leading into word problems that utilize exponential growth and decay. The page in your notebook that you should look for is this one. I'm trying to move the little webcam box out of the way. So this is the page of notes that you should look for. So it's two separate pages. It might either be two separate pages or it might be front and back. So just make sure that you have those notes before you continue the lesson. All right, so let's get started. We're going to start with exponential growth. When you are looking at exponential growth, remember that your A value represents your initial value. Or your y-intercept. So again, that's A represents initial value or y-intercept. Your B represents your growth or decay factor. And when you're dealing with exponential growth, your B is going to be greater than 1. And then the last thing you're looking at here is your X value, and X is your exponent, which typically is looking at time. So make sure you have each one of those things labeled before you move on. Now we're going to look at a real world example. So this is in the top right corner of your Frayer model. It says you deposit $4,500 into an account that can grow 5% compounded annually. Write an exponential function to represent the scenario. So what you're looking at is 100% plus 5% because you need to find your growth factor. So this is 105%. And when you're looking at 105%, to convert that to a decimal value, you would divide in this case by 100, or you just move the decimal twice, so it will be 1.05 as your growth factor. Remember your equation is y equals a times b to the x. So y equals a times b to the x power. And you would start the account with $4,500. And we said your growth factor was 1.05. And then you put in your x. So there's your equation. And the next two that we're going to look at, we're going to actually look at them in Desmos. For the table and the graph. So let's open a Google browser and go to Desmos. We're going to use the graphing version of Desmos calculator. I have to minimize it so I can try to get it all on the screen. All right, so we're going to use the plus sign in Desmos to give us a table, and our values in our table are -2, -1, 0, 1, 2. Remember, if you put in your x's first and they're in chronological order, Desmos will try to help you generate those values. So we have 1/8, 1/2, 2, 8, and 32. to get Desmos to generate the equation, we're going to put in y sub 1, a tilde symbol, so it's shift in the button right beside your 1. And then we're going to use our equation for an exponential function, which is y equals a times b to the x power. X here comes from your table, and so our x, make sure we put the subscript there. And then it tells you that your a is 2, your b is 4. So when you write your equation, that's going to be y equals 2 times 4 to the x power, which gives us that red equation that you see on your screen. All right, and then the last thing that they give us in this particular Frayer model is a graph. And what we can do with our graph is to clear out the values from this table and use some of the ones from the graph. So one of the ones that's easy to find is 0, 5. I see 110. And let's see if we can use those two to get an equation. All right, so our A value is 5. Our B value is 2. So when we write our equation, it's going to be y equals 5 times 2 to the x power, which gives you that green equation. So the blue was the estimate, the green is the actual equation, and if you look, it matches the graph that you see on your model. So make sure you write down this equation right here as the rule for the function. All right, so that takes care of the growth. Now we'll look at the decay in the next video.